It's time to take a look at one of the great integration techniques, and that's integration by parts. U substitution and integration by parts are the two primary methods that all students should know who want to be proficient in calculus. So let's take a look at what is integration by parts. Now, kind of like how U substitution is the inverse of the chain rule, integration by parts is actually the inverse of the product rule. And you use the product rule to derive it. So here you go. So what we're going to do is we're going to take the derivative of two functions f and g. Now when we do that, it's f prime g plus f g prime. Right? That's just the product rule in action. But now what we're going to do is we're going to integrate everything. Okay? So when we do that, what do we end up with? Well, let's write it out. We've got the integral of fg prime equals the integral of f prime g plus the integral of fg prime. Now, what you want to do is you want to solve for one of these, okay? It doesn't really matter which one, so let's just solve for this one, okay? So when we do that, we get the integral of f prime g equals what? The integrating fg prime is just fg, okay? And that's going to be minus the integral of fg prime. That is integration by parts. Now, you got to get used to using it, okay? But I do want to sort of highlight kind of what it does. I want us to look at this carefully. So here's a general idea. Now, if you look at f, this is f prime, and so in effect, you're integrating f here, okay? I like to think of integration as going up in powers. You just think of like x squared. You take the integral, it goes up. But g, okay, look at this. You're not integrating this part. G actually goes down in powers. And that's the key to integration by parts. And let me just set this up with this, for integration by parts, what might be considered a relatively simple example. And so let's say we want to compute the integral of x sine x, okay? Okay, so you need integration by parts for this, okay? There's no really other way to do it. So let's look at it carefully, right? If we compare x and sine of x, sine x just rotates. Sine, cosine, and sometimes they're negative, right? Sine, cosine, between positives and negatives. You never change it. But x goes away, right? If you integrate, it goes up in power. If you take the derivative, it goes down. Derivative of x is 1, okay? So you want to get rid of that x. And so the idea is what do you want x to be here? You want x to be g, right? Because if you let x be g, when you take the integral g prime, it's 1. It goes away. So in integration by parts, you actually have to choose what's g, what's f prime, okay? And so, again, I'm going to make the choice here. G equals x. And then g prime equals 1. Okay, and then, it could be nice to say 1 dx. Okay, and then what about, well, then f prime is sine of x, right? So it's not really a choice. So f prime equals sine of x. And then we need to figure out what f is. If f prime is sine of x, okay, put it up here, f equals, we just take the integral, right? So we're taking the derivative of one, the integral of the other. The integral is negative cosine of x. Okay, so now that we have, I mean, you could say f prime. Now that we have, as I said, you could say f prime is sine x dx, right? It's a little more official. Now that we have all the pieces, we can plug it in. So the idea is we've set it up so that it's f prime is sine x and g is x. Okay, so that takes care of that, right? The key is this other part. So this integral is equal to, maybe we'll just write it again, x sine x dx equals the integral, f times g. So we find it, f is negative cosine x times g is x. So it's negative cosine x times x. It's not going to put the x in the end here because, like does that mean x squared? So it can be better, it's a little more clear to kind of put it at the beginning. So we'll do that. So we'll say this is negative x cosine x. And then it's minus the integral of, now it's f is again negative cosine x. Pull out the negative, make it a plus. Cosine x, and then g prime is just dx. Right? So what we've done, and this is crucial, okay, we have taken an integral, x sine x, that we cannot compute directly, and we have reduced it to an integral that's easy to compute. That's how integration by parts is supposed to work. You're supposed to end up with something that you can compute. If you end up, if you made the other choice, right, like what happens if you make the wrong choice? If you made the wrong choice here, you might end up with x squared cosine x. Then it might be more difficult. Okay, you shouldn't get something that's more difficult to integrate. You should get something that's easier to integrate than what you started with. Okay, so the answer then clearly is negative x cosine x plus sine of x. Now it's sort of interesting, right, that this is the answer. So basically the derivative of this is x sine x. And it's a little surprising, but note that when you're doing the product rule, and when you do one of these, the derivative, maybe we should check it, okay? When do we verify that this holds? Okay, so let's do it. What we're going to do, we're going to write negative x cosine x plus sine x. And we're going to take the derivative. Okay, so what does that equal? Product rule. Derivative of the first term, negative 1, times second, negative cosine x. Okay. Plus the second term, right, that's negative x, times the derivative of this one, that's negative, which makes this a plus sine of x. Okay, so that's the product rule. And we take derivative of sine is cosine of x. And therein you see the magic because the cosines actually cancel. And you do get x sine of x. So it does work. It's a kind of an exciting one. Okay, so let's do another one. Let's consider the following. We're going to take the integral of x squared e to the x dx. Okay, so how do we do this? Well, you want to think about the same general idea here. I always think the key with integration by parts is choosing g. It's choosing what you're going to lower the power of, if there is one, to make something that's easier to integrate. Now in this case, we're starting with an x squared. When we take the g prime once, we will get 2x. And when we take it a second time, we get something like 2, right? The x will go away. So that's actually the correct choice here. We're going to need to apply it twice. Otherwise, you make the other choice, you're going to integrate, you're going to x cubed like e to the x. That's not helpful. Okay, so I'm going to write out what's what here. F prime. But the books usually write u and v. I find the u's look too much like the v, so I write f and g. It doesn't matter. What matters is you got to pick one of these. So what's f prime? F prime here is e to the x dx, and that means that f is just e to the x. Okay, so that's simple. And then g is x squared, and then g prime is 2x dx. Okay, now we have everything, and we can go ahead and plug into the formula. Okay, so I'm not going to rewrite this time. So what's this equal to? Fg. Fg is x squared e to the x minus integral of fg prime. F is e to the x, and g prime is 2x dx. Okay, so we end up with an integral and we can't compute it, but it doesn't mean it's wrong. It's actually good because we've reduced x squared to 2x. We actually need to keep going. Okay, so this is a two-stepper. We've got to do it one more time. We can do that. So we've just got to sort of redo the same thing, but we sort of have a guide here, right? Like in this case, the f prime and f can be the same, right? The difference is now we're going to choose g is 2x and g prime is 2 dx. Okay? You could pull the 2 out front, but either way is okay. So, what we're going to do is we're going to rewrite it and put something else in parentheses for this one. Okay, so we've got this x squared e to the x minus, now this is what we're changing, right? So we're doing another integration by parts on this. So it's fg. F, we said again, is e to the x. G is 2x. So it's 2x e to the x. Okay, and then it's minus the integral of fg prime. Well, now we get the nice 2 e to the x dx. And therein is the whole idea. So it took us 2 steps to bring this x squared down to 2x and then 2, but now we have something that's easy to integrate. So we can write the final answer here. It's x squared e to the x minus 2x e to the x minus 2 e to the x. And you could factor out an e to the x here if you like. I'm not going to try to take the derivative to see if it gets this. I would encourage you to check. Integration by parts is really powerful, and I will say this. It's actually not required for the AP calculus, and I think that's actually a mistake on the AP. And the reason why is just because it's so incredibly useful, okay? Anyone who goes forward in science, calculus, you have to do integrals, really use substitution and integration by parts are your dominant methods. So let's consider maybe one last one, and we get started down here. Let's look at something like this. Let's do e to the x sine of x. Okay, so based on what I've said, look, if you see an x, you often want that to be what you take the derivative of to make your integral easier. Same thing with an x squared. This doesn't have one of those. So how is this one going to work? It's going to work by sort of rotating through. When I say rotating through, think about sine. Derivative of sine is cosine, but derivative of cosine is sine. So you're going to get back with what you started. Okay? Let's see how it is. Now the e to the x is always just e to the x, so great, right? We don't really have to worry about that. So I'm going to choose sine of x to be my g, and then g prime it. So that's the one I'm going to change. Now, what you can sort of do this straight out because the f prime and f here is easy because e to the x is just e to the x. So I'm going to go ahead and just start this one. Okay, so what is this equal to? It's fg. Okay, so f because what f is what you're integrating, but you're integrating e to the x to get e to the x. G is the same, so g is sine of x. Now we get minus integral of, again, the f is e to the x, and now we do the g prime, derivative of sine is cosine, we get cosine x dx. Okay, and we need to do it again, because this is not, I mean, this is like the same thing, right? I don't know what that integral is, okay? So I'm going to use integration by parts to cycle back to get a sine of x. So I'm going to rewrite this kind of like I did here. That way I keep track of everything. E to the x sine x minus, what is this? Okay, it's a new integration by parts. So fg, f once again is going to be e to the x. G now is going to be cosine of x, right? It's the same. And then we're going to subtract the integral of f, which is e to the x, and then g prime. Derivative of cosine is negative sine. What we can do is we can change that. We get sine of x. Okay, so I'm going to write what we have up here. What we have, let's see if I can fit it all up there. So we've got the integral of ex sine x dx. Okay, that's what we started with. And we have found that it equals these three terms. Ex sine x minus ex cosine x. Yeah, we can factor out, why don't we factor out the e to the x? Save a little space. We can factor out from these two terms, right? So it's e to the x times sine x minus cosine x. Just do that to save a little space. And then it's plus the integral of e to the x sine x dx. Now this is very interesting because we have this integral equals some terms plus that same integral, okay? Think of the integral as your unknown, right? That's what we're trying to solve. Imagine it's a variable like y. So you've got y equals something else plus another y. Wait a minute, I feel like I must have messed the sign up. I did mess the sign up. Now, how do I know I messed the sign up? Because if you subtract this from both sides, you get 0. That negative needs to carry through, okay? So that negative, this needs to be a negative. Because now, again, we've got y equals something else minus y. You add y to both sides. You're going to add the integral to both sides. You take this and you add it to both sides, which is pretty cool that you can do that. So when you do that, you get 2 of them. So you get 2 integral ex sine x dx equals e to the x sine x minus cosine x. And then clearly you can just divide by 2. So you get e to the x sine x dx equals 1/2 e to the x sine x minus cosine x. Okay, I think it's almost kind of beautiful in a way because this is probably your first time here sort of treating an integral like an unknown variable where you get 2 of them and you add them together, right? You got 2 here, you just divide by 2. So sometimes when students see that for the first time, they're like, wow, you can do that? Yes, right? Because the integral is just some like mathematical entity, right? And if it's an unknown, of course you can treat it like a variable, right? It's the exact same. And so if you have 2 of them, yes, you can put them together, okay? So that's integration by parts. Again, what's the key? For integration by parts, the key is you have the formula. Okay, this is the formula. And what you want to do with this formula is you want to think hard about what do you want your g to be so that when you take a g prime, it's easier to integrate, right? If you have an x, g prime, like if it's better for you when that x goes away, make that your g, right? Look, e to the x isn't going to change, right? You know you could take the integral of e to the x times any constant. So it's the other in the x squared that you need to bring down twice. In this particular case, you know, nothing's going to disappear. So what's cool though is because sine cycles, you know, you can cycle through a sine to get your answer.